Well, thank you very much. At least this seems to work. I've never been accused of speaking softly, but I guess we need this for the recording. So yes, thank you. First I have to say, I did lose my presentation partner this morning, Jim Whaley. Besides him, his day job being running the company, his job for presentations is also containing my Joycean tendencies. So if we go off on some tangents, yeah, be prepared for that. As a quick introduction to myself, besides being a mediocre rugby player, I am a researcher, especially almost 40. I am a researcher by trade, but I started off my career 16, 17 years ago, actually at a Silicon Valley startup doing AI and machine learning for behavioral science, modeling human behavior, except back then that was pre-generative AI. So we had a small army of computational linguists and mathematicians building these ontologies and writing new algorithms, except all that was for certain intelligence communities and a couple hedge funds for counter-espionage. So a little less of the spooky, squirrely stuff now, but we are being exposed to technology that has been hidden for a little while, and now we're actually able to use. My other one is, how many people in here have heard of the AMSR, the Archive of Market and Social Research? We've got a few. For anybody who doesn't know, it's an awesome repository. You can go on their website, and really it is decades and decades of market research reports and polling data, et cetera, in the United Kingdom. So it is a great resource, not only out of curiosity and from a historical perspective, but we've also used some of the information from there to influence our own studies and as a baseline. So what I'll be talking about today is what we're doing currently for the AMSR. Ovation has been a big supporter of them. I guess I could just start moving this one. So what do I do? Well, I can just wing this, but here we go.
There's indeed a blank screen.
Okay. Which button do I go?
The right one.
Oh, there we go.
Yeah.
I think I hit stop. Maybe that's why. What we're doing with them is, so currently on the website, there's more traditional search functions. You can do keywords, choose which parts of the archive, what set of reports you want to look at, maybe what category. But what we wanted to do was allow people to engage with it in a more conversational manner. So, you type in a query like you'd be talking to ChatGPT and get a response back, answering your query, but that's based only on the information in the archive. Because an issue, of course, if you take a large language model, and we don't use anything from OpenAI or from Anthropic, this is all kind of a closed internal system. But if you point one at a set of data and say, when you prompt it, hey, just use this, when you're formulating your response, it ain't gonna work, right? There's still a big risk of hallucination. So what we're gonna talk about today is how we incorporated something called a vector database, some technology that's been around for a while, to help augment this. Basically gave the background already. So for the project overview, we had our goal. Like I said, it's to create that environment where somebody can come in. You're good. I'll just point it out. Late to class. My dad's a professor. But so our goal is for users to be able to engage with it in a new form of search in a conversational manner. So to do this, we had to identify, okay, what do we need in our tech stack? And from that was, first we'd start with a vector database, and I'll explain more about how those work. That's going to be storing the data, processing the data, storing the data, allowing for retrieval, and then using the model for those conversational responses, but again, limiting it to the information retrieved from the vector database. So the way we process this is, first you have your data collection, and all of the information in the archive. So all of the information in there had been digitized, so it was all in PDF format, we had the text. In other cases, you may have to use OCR first, extract that. And then, so as that all had been cleaned, normalized, we had it. Otherwise, sometimes you can run into issues with normalization needs to happen first. So let's say my first coming years and years ago, we also did some work for UL, which anyone who's not familiar, at least in the States, does pretty much all of the safety testing and certifications. But the thing is if you look from over the years, somebody might say 20 watts or 20 W or W20. Sometimes you do have to normalize these. But at that point, the data goes in, and as that text in each document is being read, the system, when it's quote unquote vectorizing, what it does is it looks at blocks of text in each page. It looks at the context, so not just keywords, but what it means, and assigns a numerical code. So essentially this is automatic coding. And each block can have multiple codes, if there's multiple bits of context. So this is kind of like your, if we're doing this manually, if I was a Max QDA, of course I do my in vivo coding first, build my way up to higher order categories, and eventually higher order themes. So once these numerical codes have been generated, it's stored in a vector database. And the way this would look, just kind of imagine it, is it's stored, it's all graph based. So, you have your cloud of data, and in that you will see darker categories where more codes, more data points are clustered, and those are going to be similar in theme. I'll need to go through all this. This will be are the presentations available?
There will be.
Okay, so you can look at this. Like I did put in a few graphs, really to show the process of how this works in a little bit more detail. So I have the query processing. So I want to ask my question. I'll show an example query later, but let's say, did anyone have a positive opinion, or what were positive opinions about Margaret Thatcher? Then you could get, we have all this political polling data in there. What it will do is, after you've entered your query, similar to how the data was coded into the database, is it will actually assign a code to your query based on the context of your query. And what will happen is it then looks, okay, it's like, where would I put it in this graph-based environment? And based on that, it wants to pull the blocks of text that are most closely related, most closely coded to that query. Now, when those blocks are pulled, the next step is, we'll get into a little bit more detail, we want to look at the relevance of each of those to the query. There's some different algorithms that do this. So then we have, in rank order, the blocks that seem to be most relevant to your query. And at that point, this is where the large language model comes in, and we keep under very, very, very tight parameters so it doesn't get creative. But we'll look at that, look at your query, and give you a relevant response based on the extracted data. Again, something to review a little later, because this starts with your search query and goes all the way back to how you get your result. With the relevance scoring, this is, like I said, we enter it, and not only do you have the blocks of text closest to your query, we do use a couple, like some examples. One that's been around for a while is term frequency. And that one is based more on words that are in there. As I said, while the search isn't keyword based, of course words are going to be very closely aligned in the database. We also do have cosine similarity, because essentially we're analyzing space here. So it's not just frequency, it's, where in space do these documents exist compared to your query. But you do have some risk in this. I can touch on a little bit after this. But this is where the large language model gets integrated at that point to create, you can ask it just to summarize, it'll summarize what comes back, or it can get your more detailed response. And this is, like I said, we don't use OpenAI or Anthropic, any outside APIs, but you could. Nothing stopping you there. The only problem with those is, maybe unless you have deals with the organization, it is harder to tweak your parameters, do your own training. Beat it into submission is honestly sometimes the only thing that you can do. So here's a query I ran a little before. I was going to include a picture of my cat, but Slide Designer used this one. Happy to show you pictures later though. I said, okay, how did people view cat ownership in the 1970s and 1980s? And this is an example of what the language model put out. We'll also see that you can also view the raw results. Let's say cat ownership seemed to be gaining popularity. It'll compare, there were two main surveys, and it talks about the percentage difference in both. Gave top reasons why people did like them, what they used, what their concerns were, how much they spent, and a summary there. And you can use a model too. You could go even further and say, okay, based on this, write me a song, I suppose, and based on the kind of model you were using, someone would be better than that. Or you could say, write a few paragraph paper on this. Or even what I mostly use it for is, I can see the initial result. Let's say I want to dig in a little bit more, and if the data's in the database, like, okay, why do they think that they're less trouble than dogs, right? And if you don't have the information there, you don't. But there are many cases where you can dive deeper. And I will say that percentage-wise, so when data is extracted, sometimes tables are cleaner than other times, and especially when you really go back in history with some of these reports, it can be a little tricky. And so what I always tell them is, let's go look at the original document just to confirm those, because it's good, but not perfect. Now these would be the raw results. So you can also access this, and really where it's kind of an enhanced search function, because I see the blocks of text that were coded from the original documents, and these are some of the most relevant. And on this you can click on the document itself, go straight to the source, and review it. So if you are going through the archives, you want to dive deeper yourself, you can do that as well. And so that's why we mentioned this being a librarian, right? Because it'll help guide you through the process. You don't necessarily have to make sure you get the exact right keywords, especially if you're exploring the archive to begin with. And so we wanted a bit more of a personal touch as a way to engage. It's a more engaging experience. And you could also, and something, our priority first whenever we do a project like this is let's tighten everything up, right? Let's make sure we're getting accurate responses. They're based only on the data in here. And then maybe we can loosen some parameters if we wanted to get a bit more creative, or if we wanted it to have kind of a certain personality, like you can do that. It's always just a balance. We figure this can be a broader audience engagement. Target users, researchers, of course, have already been in the archive, use it a lot. There's also academics, academic researchers that use it for social histories, psychological histories, but also, maybe you don't want to use those traditional search methods, or I'm coming up with stuff in my brain, haven't formulated it fully yet. Let me ask some questions. But also non-researchers. There's been talk lately about using journalists to promote the MSR. Maybe they can't or just don't want to be diving in, reading all these original documents, right? They want to get the highlights on a certain topic and go from there. or students. This broadens the user base, potential user base of the archive. And now if you think about this too for corporate applications, you can apply this methodology to, let's say, a client of yours has years and years of research reports, right? And especially if you go back away, sometimes some of those may just be stored on someone's computer. You know, people may not know where they are, or even if they are all together, you know, you say, how do I find this? How do I find that? This is a way for really anyone in the organization could query that database. So we talked about Pepsi earlier. I want to go back and see, you know, how it performed against New Coke, right? Or people's opinions about the two. That would come up. You get a response and dive. You also find where those reports were just from asking the question. So this technology does have other applications. The future direction. You know, there are continuous improvements on this technology. With large language models, generative AI, people will ask me, oh, can you do this thing yet, right? And if the answer is not yet, or I don't trust it, you know, to do that yet, it's like, I don't even say give it a year. A lot of times it's give it a few months. Sometimes give it a few weeks. So you want to remain flexible and be able to implement new models as they come out. Like we've been watching a lot of the multimodal ones. You can see that with ChatGPT as they use image and video, and your output can be in those formats as well. Since we don't want to use them, we haven't found really great ones that we can kind of base a new tool around yet, but we're keeping our eye on that. It'll come soon. Applying a solution to other types of data, like I said, the market research reports, if you wanted to, and also just implementing user experience feedback so we can customize this for our users. So not only listening to the AMSR, but once we engage the public and using that as well, we can make changes. And welcome back, actually I mentioned the risk. I'm going to touch on that one more time because, again, the risky part with the vector technology, any risk, I suppose, is maybe something wouldn't be coded exactly the way that you wanted it, or might be not as relevant when it gets recalled, but you don't have a risk of something being wrong or outside of your data, right? The risk always comes when you're implementing the language model to summarize or to give you answers, because again, you have to make sure it doesn't revert to its initial training and bring anything in from the outside, and that's where you can look into, if you look into different parameters, like you've probably heard of like temperature or, you know, top P or top K, things like this, and just the general prompts of how you want it to behave. This is all stuff that you kind of need to tweak, experiment with, fail a lot until you dial that in. So in conclusion, I just want to wrap up by saying, you know, if you're not aware of the AMSR, go to their website. If you are aware of them, but maybe haven't been in a while, really check it out. We did a study recently about the experiences of male and female entrepreneurs, and we found, it's kind of a baseline, I actually went into the archive and found a study from 20 years ago that it was a qualitative study, and so we wanted to see, okay, maybe what has changed since then, what's probably unfortunately still the same. And so we ran a study with the same target audience, but used it with our AI chat functionality, and then analysis to compare those. So it does have applications to our work today. Highly encourage using it, sponsoring them. They can always use sponsors. So I won't pitch my own company, but I will. I will pitch them because it's an important part of our industry. So that's mine. Spiel.
Great presentation. You know, maybe you should have asked like what are the good things about Liz Truss, but maybe the field of data would have been even smaller. It's fascinating. What I love about it is the fact that you can interrogate the AI and get the sources. You know, we know that one of the dangers is hallucination. So I was trying to understand how it works. So you've got your prompt, you know, I don't know if you use correspondence analysis to do your cloud of words or what, and then you select documents and then you feed them to the LLM. Is that how it works?
Yeah, so on the vector side, and this technology has been around for a little while, just wasn't used as much, until we could integrate this, is the query is treated the same, it's basically processed the same as the data is that goes in. So it's essentially, it's coded as well. So if we look at, let's say, so the cats, some surveys would have come in or reports would be there about pet ownership, right? And as that data is processed and it's looking at blocks, say one code that would be automatically assigned would be about cats, right? And some others that have dogs. There might be cat food in there. There's a lot about that actually. And then when I write my query, I'm asking about cat ownership. Well, it'll see that, okay, this, I'm going to assign a numerical code to it based on this. And then that's how it's able to place. It places your query into the graph. And that's where it finds, okay, relevant blocks of text. Then it does the relevance score to see how many are there. And then what the model, the LLM, is looking at is just those blocks and those documents that have been
So do you use correspondence analysis to plot, in that space?
I mean, it's
Find
similar.
proximity?
Yeah, it's similar. Because, and that's why to find the relevance is it's based on, directional vectors and stuff as well.
Okay.
Yeah. And geometry that goes back to my high school days that I probably can't.
Yeah, I mean, a lot of it has been done in France. There was Ben Zekri that done a lot of things on numerizing text and trying to find. He worked on a lot of union text, syndicate, and also on the Bible, and that's how I got hooked into microservices actually through analyzing text, numerizing them, and so it's one of my passions. Any questions from the yes, John?
You talked about text. How are you working with more broader survey data? How are you mapping out, I've got a survey with a whole load of columns and a whole load of rows. I've got the questions. Have you got any framework to transpose that into a text-based language?
So it is best, this is kind of what I was talking on tables, I mean this, especially when we talk about, large language models, is they are based around lexical data. So what is best always is the summaries of those tables, and what people have said about them, what the reports are, if there is open-ended data. Now that said, if the table has been easy to read in, then it can pull the relevant, say if there's percentages there. Now it's not doing quantitative analysis. I mean, you would go a different route if you wanted to actually put in a survey and do your clustering and all that. Like what you were talking about, you would cluster, say k-means or LCA, PCA, on that quant data and use that to influence it. So it's not good for analyzing quantitative data, but it can extract percentages, relevant percentages from tables if they're formatted in a way that's kind of easier to process. So that's why I always give the warning. That's why we have like the underlying data there. That it's like, look, if it gives you a percentage, go to the source document to confirm. But when it comes to putting together, piecing together lexical results, like summaries from research reports and all of that, it's very, very good at that. I was just trying to be conscious of square peg, round hole situations.
It's quite a simple question. So, did you use any off-the-shelf vector databases, anything like QDrans or anything like that?
So we did, as we started to use it, so all the data itself was AMSR, but there are, kind of like how Pinecone operates, there are base open source models that you can use for vectorization. And then our storage was S3 and AWS.
So you use Pinecone, right?
No, so like what Pinecone does is they are based around certain open source tools that they package, kind of like a Red Hat model. So instead of doing that, like we just started with some of the open source tools and tweaked those to our own needs. Nothing under a non-commercial license, promise.
Any other question? But it's, you know, it's the last thing to before the break, so I think everybody's keen to stop. The company is Ovation MR, they're great. So I'm doing the you know, a bit of pushing, and you know, and they used to share an ASC New York with Askia, which is small sort of a company that I know well. Thank you very much. Thank you.
Thank you for having me.